Hey everybody, and welcome to McArdle Math Academy. In this video we're going to be talking about integration using the trigonometric substitution technique, and in particular we're going to talk about how to set up the triangle for each different type of trig substitution that we use. So let's first look at a triangle where we have side lengths A, B, and C, and we know by the Pythagorean theorem that C squared is A squared plus B squared. Alright, so the way that we set up our triangle for all trig substitutions has to do with preserving this Pythagorean theorem. Alright, and what do I mean by that? Well, let's take an example. Again, here's the same setup, A, B, and C. C squared is A squared plus B squared. If we solve this for C, we find that C is the square root of A squared plus B squared. Okay? So we might as well, take this, square root of A squared plus B squared, and replace C as the hypotenuse of this triangle. So here's what we get. Alright, so this triangle setup is what we're going to end up using for a tangent substitution. And we do that because it preserves the Pythagorean theorem. And it's got this type of substitution is going to work for integrands of the form u squared plus a squared, and you can have, for example, it would work for the integral of 1 over x squared plus 25 and things of this type. Alright, and you'd set up the triangle in this fashion, which we'll do a couple examples of. But this is why we set the tangent substitution up with the triangle in this way. Alright. And then setting it up in the same way now, if we solve for a, you're going to find that a is the square root of c squared minus b squared. So you can take this and replace the a term on the triangle to still preserve the Pythagorean theorem. So we end up having a triangle that looks like this. Now this triangle setup is what we're going to use for sign substitutions, which we'll do a couple examples of in the end here. And this is going to work for integrands of the form u squared minus a squared. And you might have a square root on these integrands. So for example, it would work for something of the form square root of 25 minus x squared dx. And you'd set the triangle up in this way. Alright, so let's do two and a sign substitution. So on this particular one, because it's of the form u squared plus a squared, where u is x and a is 5, we're going to use a tangent substitution. And so as we talked about before, to preserve the Pythagorean theorem, we're going to take this sum of the squares, so x squared plus 25, introduce a square root to keep the Pythagorean theorem satisfied. X will come over here, and 5 will come over here. So that's how we'd set up our triangle. Alright, and if you check out some of the other examples, you can see how we get from setting up the triangle to actually introducing the change of variables in the integrand. As a last example, when we talk about this form, this has the form a squared minus u squared, where a is 3 and u is x. And this warrants a sign transformation. So we set the triangle up as we talked about earlier in this video, where that square root piece comes right down to the base of the triangle. You'll get 3 up here and x over here. And again, check out some of the other videos to see how we then make the substitution into the integrand. Alright, hopefully this helps, guys, and I'll see you next time.